Numbers with Nicole. We're going to go over some problems where you have to solve multi-step trigonometry problems. This may involve using trig more than once, or maybe you have to use some other knowledge of right triangles that you know in order to do this problem. Or maybe you have to add things together. So that's what I mean by multi-step. It doesn't necessarily have to be trigonometry and then more trigonometry and then more trigonometry. So take a moment to read the Now You Try question number 1, see if you can do it on your own, and then press play when you're ready to view the solution. So for number 1, part A, you should get 84.84 to the nearest foot. And then for the bottom part, you should get 71 for the nearest foot. So now let's go over those solutions on how we got those specific answers. If you already got that, you can move forward a little bit into the video until you see the next Now You Try problem. So we want the height of the balloon directly above the ground. I'm going to call this X, not H. Again, H could be in hypotenuse, and I don't want to get confused. So then I want to look at what I'm given. They gave me the hypotenuse H, so again, that's why I'm not going to use H, and I have the opposite side is what I'm looking for. So I'm going to use so. I can't use Pythagorean theorem because I only know one side. So the sine of the reference angle equals the opposite x over the hypotenuse. And when we solve this, we want to put our sine 50 over 1. So we get 110 times the sine of 50 equals x. And when we round that, we put that in our calculator. We get 84 to the nearest foot. All right, and now we're going to add that to information that we know. We have lots of options for the second part, for part B. So now that we have 84, what could we do? Well, we didn't need that at all to find the distance on the ground, which is this distance here. So I'm going to call that D. All right, so I could have just used cosine of 50 degrees equals the adjacent D over my hypotenuse of 110. And when I solve that, I'm going to get D equals 110 times the cosine of 50. Or I have two sides of this right triangle now, so I could use Pythagorean theorem. Okay, and I could do 84 squared plus D squared equals 110 squared. So D will equal the square root of 110 squared minus 84 squared. Remember, you have to follow order of operations there. I also, instead of using cosine, could have used tangent now that I know 84. Tangent of 50 degrees equals 84 over D, the distance I'm looking for. D equals 84 times the tangent of 50. And regardless of which one of these that we do, we're going to get an answer of 71 when rounded to the nearest foot. So here is the second question. If you haven't tried this yet, please pause the video and then press play when you're ready to see the solution. So we want to find the height of the lighthouse X. I don't have two sides. I can't use Pythagorean theorem. I have an angle and one side. So I'm going to have to use trigonometry, and I'm going to do two triangles here. So I have this smaller triangle, which gives me the cliff here, the cliff which I'm going to represent with C. All right, and so in this smaller triangle, I'll resketch it here. That's a terrible right triangle, but we're going to go with it. And that's my smaller angle of 18 degrees. So I have tangent of 18 equals the opposite over the adjacent, which is 200. And when we solve this, 200 times the tangent of 18 equals C. Now these numbers are going to continue on. I would have to round these, and I don't like to round until the very end. So when you see me finding a value, I'm not actually calculating that until I'm done with all of them and I find them all, everything that I need to do. So now I'm going back up to the picture and I need another right triangle. So if I have this total distance here, so I'm going to call that T, this total height, that angle, that right triangle that's formed, that's that 28 degrees one. So I'm going to draw that nice big triangle here. That one was a little bit better than the other one. So now my angle is 28, and I have this capital T. So what is capital T made of? Capital T is made up of x plus c. So I've found c. If I find t, I can then subtract them to get x. So I know x will be t minus c equals x, right? So if I find this total height and I subtract just the cliff part, then I should be left with x. So let's go back to our problem. I have the opposite and the adjacent. Tangent of that angle 28 will equal the opposite t over the adjacent, which is 200. And we solve 200 tan 28 will equal t. So now my last step to get x is to subtract those values. X equals t minus c, which I will do directly in my calculator. 200 tangent 28 minus 200 tangent of 18. We get 41.35, and let's see, they wanted us to round to the nearest tenth, so that is 41.4. All right, we have our last regions problem here. So again, pause the video, press play when you're ready to see a solution. They go through a lot of stuff here. They said that the step runs parallel to AB. So here's my little step. That runs parallel to AB. What does that help me get? That helps me to get an angle in these little triangles, which are all equal to one another, right? These little steps are all equal. And these three smaller triangles are similar to the bigger one because they are similar by angle. That would be helpful if we had more than one side, but we do not at this time. Then it told me that this has a length of 10 inches. So each step has a length of 10 inches, and we want to find the rise of the step. So this little distance here. So I'm going to redraw this little triangle here. That's what we're going to be focusing on for the first part of this question. H, A, G. I got that 36-degree angle by using the fact that the step, which is 10 inches long, is parallel to the base of the stairs, is parallel to the ground. That's where I got those alternate interior angles, which are equal. So again, geometry loves alternate interior angles. And we're looking for the rise, which is this amount here. So I'm just going to call this rise. That's what I'm looking for. So what do we have in terms of this reference angle, this 36 degrees? The opposite over the adjacent. I'm sorry that all of these use tangent. So we have the tangent of 36 equals the rise, which is what we're looking for, over our adjacent, which is 10. We solve 10 times the tangent of 36 equals the rise, and that did give us where to round on that question. That's just the first part. So tangent 10 times tan of 36, that is 7.3 inches to the nearest tenth of an inch. So we've done the first part. Let's do the second part. Determine and state the length of AC. Okay, so again, all these steps are parallel to that bottom, so all of them have an angle measure of 36 here. These three steps are similar by angle, okay, and the three steps are congruent. They told you that. The three-step rises and the three steps are congruent. So if we can find AG, if I could find how long AG is, and if I multiply that by 3, then I get AC. So there's my plan. AC equals 3 times AG, because I know all three of these little pieces here are equal, right? These triangles are equal. Okay, so how do I find AG? Well, I found the rise of 7.3. I have 10 inches, and I have this 36, and here's AG, what I'm looking for. We have lots of options again. We could use trigonometry. We could use Pythagorean theorem. You choose whatever option you want to use. So I'm just going to do the sine of 36 equals 7.3 over AG. And I'm going to swap these two, because if I solve through cross multiplication, what happens is they just switch places. And I'm going to go to my calculator. 7.3 divided by the sine of 36. And we get that AG is 12.4. And we're going to multiply that by 3. So AC is 37 inches.